Welcome back. All right, so let me point out some things that I noticed. All right, so, well, I'm going to write up on the top here. First, I noticed that, 1 plus 2 equals 3. So if I added the exponents, if I added the exponent, the answer for log 10, and I added the answer for log 100, I would get the answer for log 1000. And going along, I also notice that -1 plus -2 equals -3. And 2 plus 3 equals 5. So notice that if we added the exponents, the answers, right, for log base 2 of 4 and log base 2 of 8, we would get the same thing as we got for log base 2 of 32. And likewise, if we add the exponent for log 1/10 and log 100th, we get log 1000th. Okay? That's one thing I noticed. Let's see, what else did I notice? I noticed that if I were to take the result, so what we're taking the log of, if I were to multiply those together, so 10 times 100, I would get 1000. And if I were to multiply 1/10, right, which is this one right here, and 100th, I would get 1000th. And I also noticed that if I were to multiply 4 and 8, I'd get 32. So I kind of see a relationship here, that the sum of my answers is equal, and the product of what I'm taking a log is equal. So maybe that means that log 10 plus log 100, since I get the same thing on both sides, maybe that equals log 1000. And maybe log 1/10 plus log 100th is equal to log 1000th. And just perhaps, log base 2 of 4 plus log base 2 of 8 is equal to log base 2 of 32. Since we get the same things, if the sum of those exponents for the individual logs is the same as the exponent I get for the log that's the product of those two. So perhaps I can just add the logs and I'd get the same thing for the log as of the product of those two. That's what it looks like to me. I wonder what it looked like for you. Because actually what I've just demonstrated here is something called the product rule. And it's the first property that we're going to learn about in this particular podcast, the product rule. Because remember, logs are exponents. So any property that holds for an exponent is going to hold for a log. Right? And I have just demonstrated the first one, which is the product rule. So that the sum of the logs is equal to the log of the product. So log 10 plus log 100 really does equal log 1000. And log 1/10 plus log 100th really does equal log 1000th. And log base 2 of 4 plus log base 2 of 8 really does equal log base 2 of 32. It's called the product rule. So I hope you enjoyed that little activity, and I hope that will make this next slide make lots of sense. I'm waiting for it to change any day now. There we go, the product rule. All right, so let B, M, and N be positive real numbers. So we have log base of some product. It is equal to the sum of log base b of the first one plus log base b of n, right? So if I've got a product that's m times n, that log of the product is equal to the sum of the individual logs. So in other words, the logarithm of a product is the sum of the logs. So and just to compare this to exponents, because remember, logs are just exponents. It says it right down there. Remember, a log is an exponent. To multiply like bases raised to a power, we add the exponents, right? So down there I have a little example, right? X to the 5th times x to the 3rd. You would add those, right? That's equal to x to the 8th. When we're simplifying the log of a product, we simply add the logs, right? So the sum of logs is equal to the product of a single log, or we can split a log up and we can take a product and split it into the sum of the individual logs. Let's see what that looks like when we have some numbers in here. And we actually saw that in that last activity. There we go. So we have the product property. I have these in your notes for you, and you'll fill them along with me. And over here, I'm just going to move this around a little bit. Over here, we're going to expand. So notice at the bottom there, it says, the product of two logs can be expanded as a sum. So maybe we don't want it to be a product. Maybe we want it to be two individual logs. Because sometimes it's easier to evaluate than when we separate them. Maybe we don't want two logs. Maybe we want it to be the product of a single log. Well, we can do that as well. So the product of two logs can be expanded as a sum, and the sum of two logs can be condensed as a product. All right, so let's see what this looks like. Super easy, really is. All you have to do is remember that since these are exponents, when we're multiplying exponents, we add, right? So if we're multiplying two bases raised to a power, we add the exponents. Logs are just exponents, so I can take this product and turn it into the sum, right? Because that's what we would do if we were multiplying, right? Exponents. So log 2 of x is just log 2 plus log x. I can separate that product out into a sum and have the individuals. And we saw on the last slide, or 2 slides ago, that sum was equal to the product of the single log. We can rewrite log base 7 of 5x as log base 7 of 5 plus log base 7 of x. Right? It's really easy to expand and condense. And as you work with this more and more, it'll begin to make more and more and more sense, right? And it'll be easier and easier and easier for you. All right, so this is your introduction, though, to this topic. All right, and we can condense that as a product. All right, so I can write that as a single log. The sum of two logs or more can be rewritten as the log of a single product because they are the same. If I add the exponents, when we add the exponents, it's the same of the exponent I get from that single product. All right, so log base 3 of x plus log base 3 of 4 can be rewritten as log base 3 of 4x. Right? I could have put an x4, but that's not normally how we write when we have a number times a variable. We usually put the number first. Log base 2 of 6 plus log base 2 of 5 is the same as log base 2 of 6 times 5, which I could rewrite as log base 2 of 30. All right, so you can take the sum, condense it to a single log. You can take the log of a product and split it and make it the sum of each of the factors in that product. Super easy, the product property. Let's look at the next one, which is the quotient rule. All right, so if we add exponents to multiply, what do we do to divide? We subtract exponents. All right, so let b, m, and n be positive real numbers. So we just have some log, a log of some number. We have the quotient of a log of some number divided by some other number, or some variable that represents a number divided by some other variable that represents a number. We can take that quotient and change that into the difference of logs. So in other words, the logarithm of a quotient is the difference of the logarithm. So to divide like bases raised to a power, we subtract the exponents. When simplifying the log of a quotient, we subtract the logs. So if we had x to the 20th divided by x to the 5th, that would be the same as x to the 20th minus 5 or x to the 15th. Because a log is just an exponent. So the exact same properties that apply to exponents apply to logarithms. So let's look at the quotient rule. So if I have the quotient of a single log can be rewritten as the difference of two logs. And we can condense and we can expand. And these are in your notes, so you'll do them along with me. All right, so log base 3 of 10 divided by x is the same as log base 3 of 10 minus log base 3 of x. Because sometimes it's easier to work with the individual the logs in the numerator and denominator separately as opposed to together. And you'll see that a little bit more when we go to solve equations where we have logs. Getting tongue-tied today. Log base 4 of 2 divided by x, we can rewrite that as log base 4 of 2 minus log base 4 of x. Now, whenever we can simplify, we need to simplify. This can be simplified. So you're looking for things you can rewrite without a log. We can rewrite that without a log. So next to that, let's write simplify. And maybe put an exclamation point so we don't forget. So the power I have to raise 4 to get 2, well, that's going to be the square root of 4, right, is equal to 2. And how do we write a square root as an exponent? That would be 4 to the 1/2 that equals 2, right? Kind of writing in my words there. So we can rewrite log base 4 of 2 as 1/2. So now this is 1/2 minus log base 4 of x. So now we don't have the log of a quotient. We don't even have two logs. We just have the difference of a constant and a log. And if we were solving this as an equation, this is now much easier to solve because there's only one log in there. And the only thing with the log is just an x. All right, so now let's take a look at condensing, because sometimes we want to go the other way. Right? We don't want two logs, we want one log. And you'll see that when we condense these, we're going to have some simpler logs. So log base 2 of 125 minus log base 2 of 5 can be rewritten as log base 2 of 125 divided by 5. Well, I can reduce 125 and 5, right? 5 goes into 125, that's just 25. So now I've got log base 2 of 25. So now I took something more complicated and made it a little bit simpler. We're really going to make the next one simpler. So log base 2 of 9 minus log base 2 of 18. We can rewrite that as a single log. So that's going to be log base 2 of 9 divided by 18, because the difference of two logs is equal to the quotient of a single log. Well, I can reduce that. That's just 1/2. So now I've got log base 2 of 1/2. But wait a minute, we can rewrite that because, oops, I meant to write 2, not in a box. 2 to what power is equal to 1/2? Well, we just have to raise that to the -1 power to make it the reciprocal. So this whole log statement here, log base 2 of 9 minus log base 2 of 18, that's really just -1. That's just a more complicated way to write -1. So now we've made that much simpler by rewriting that log. And we have one more rule, and that is the power rule. Right, so let b, m, and n be positive real numbers with our base does not equal 1. Not equal to 1. And p and let p be any real number. So we have a base. Obviously, our base can't be 1. Otherwise, just like we can't have 1 as a base on an exponent, we can't have 1 as a base on a log, because 1 raised to any power is just 1. That's very, very boring. All right, so that's just a horizontal line. That's nothing exciting at all. All right, so in other words, if we have, so let's take a look at this rule here. So I have a log, and it has an exponent on it. That's the same as the product of the exponent and the log. So if we think about what do we do when we have an exponent raised to a power, we multiply the exponents. Well, a log is just an exponent, and that exponent's just an exponent. So we can just simplify that by making it a product. So the log of a number with an exponent is the product of the exponent and the logarithm of that number. By raise a base raised to a power to another power, we just multiply the exponents. When we're simplifying the log with an exponent, we multiply the log by the exponent. All right, so for instance, if we had x to the 5th, all raised to the 4th power, we would just make that x to the 20th power. We'd multiply those exponents. Well, log is just an exponent, and we can do the same thing. If we have a log, which is an exponent, raised to a power, that just means we have an exponent raised to a power, we're going to multiply it. And we can go the other way as well. So if we have a product, we have something multiplied by a log, we can move that back and make it an exponent. Let's see what that looks like. All right, so we're going to rewrite all of these, and we're going to simplify those, and we're going to either A, we're going to condense it, or B, we're going to expand it. All right, so the exponent becomes the multiplier, and a multiplier, and that's the same coefficient, a multiplier becomes an exponent. All right, so first of all, let's just rewrite the two terms that have radicals, because I can't work with a radical in a log if I want to rewrite it. I can't use the power rule for a radical. It has to be an exponent. We can rewrite this first one as log base 6 of x to the 2/3. Right? It's power over root. And we can write this next one as log base 4 of x to the 3/5, power over root. All right, so now we can go ahead and rewrite all of these using the power rule. All right, so here I have something raised to a power. That's the same as the exponent, 2/3, times the log base 6 of x. Because sometimes we want to get rid of the exponent. If I had to solve this, I would much prefer that exponent move in front, because I can get rid of that, right? If I had this as an equation, I could just multiply both sides by 3/2, and that exponent is gone, right, because it's a coefficient. But if it's up as an exponent, it's hard to deal with it. So sometimes when we're solving equations, it'd be a lot nicer to get rid of the exponent. And we can do that with a log, because a log of something raised to a power is the exact same thing as that power times the log. All right, let's look at this one. Well, there doesn't seem to be anything to simplify, does it? But we could rewrite that as log base 2 of 25. What is that? 5 squared, right? So now I've got something with an exponent. I can rewrite that using the power rule and move the exponent in front. So log base 2 of 25, which is the same as log base 2 of 5 squared, is the same as 2 times log base 2 of 5. Look at that. Sometimes maybe we don't want the coefficient. Maybe we want to move it back as an exponent. And we can do that. So 3 times log base 2 of x is the same as log base 2 of x cubed. Right? The exponent can move back. All right, let's rewrite these last 3 here. All right, so power rule, the exponent can move in front. Log base 4 of x to the 3/5 is the exact same thing as 3/5 log base 4 of x. All right? This is kind of like the one right above it. I don't have any exponent here, but I could rewrite log base 4 of 36 as log base 4 of 6 squared. Now we have an exponent, it can move in front. 2 times log base 4 of 6. And then the last one, if we have a coefficient in front of our log, we can move it back as an exponent. So 5 times log x is the same as log x to the 5th. And there we go. These are simplified. So individually, these rules are pretty easy to use. We can also combine them and use multiple rules to simplify and expand or condense our log statements. All right, so I may do one more podcast. If you see another podcast, well, then watch it. And if you don't see another podcast, I decided to save everything else for class. But I might do one more short one. All right, so bye for now.